Okay, so let's talk about the cycloid today. A lot of people think cycloid is very difficult to calculate, but actually, if you know the concept of it, it's not that difficult. So today we are going to introduce the application of parametric equation when it's used for cycloid calculation. So let's start. Okay, I already draw a picture here. So first of all, we have 2 points here. So this is a circle, right? So we all know the feature of the circle is that it has a center point and it has radius. So let's mark it down here. Your C will be, because here is at a 0 point that we assume. So your X value will be 0 and your Y value will be your R. Yeah, your radius R. Okay, so now as it moving forward, there's a P here. Okay, let's point this down. Okay, your P over here. Let's make it bigger, so easy to see. So assuming your circle rotate and it move from here to there, okay, maybe here. So let me see, here will be your new C. I forgot to make it different layer, so now I need to erase like more carefully. Okay, so now this will be your new center as your circle rotate forward, which let's assume it's called C prime, and let's assume its value will be I don't know, let me think, maybe A and B. Okay, A and B. And also you got a new point. Your P, not new point, I mean like your P will be in a new location. Okay, let's move this down here. Your new point, your new location of your P point will be here. Okay, let's mark it down different color then. I think it's not obvious, sorry. Okay, maybe yellow. This will be your P prime, which let's assume it's C and D. I know it's that, yeah, but it's easier to distinguish. So now I think the main point of calculate the cycloid is this part. So what I'm going to say is very important. So as your circle rotate, we need to then we will use the feature of the circle to find out each point's relationship. So as you moving forward, you rotate theta. And as we have the theta here, then we will know this value. And once we know this value, then we know from the beginning point to here will be the same. Okay, let's mark it down. Okay, the same. So we all know how to calculate this curve because we know the value will be r theta. This we all know. But why? How does this come from? Yeah, let's just rehearse a little bit. Because you rotate theta angle, and then all in all, one round is equal to 2 pi, 2 times pi, which is 360 degrees. And theta will be a portion of it, like how much you rotate, like with related to the whole circle, which we got this portion. And then this percentage, we times 2 pi r, which is your circumference of the circle. Then we get r theta. Okay, cool. So now we know this is r theta. I want to assume it's a different. I want to assign a new name, but maybe not. I don't want to like have too many variables and let people confuse. So now just remember this color. That each one of them have different color, so it's easy to see in the picture. So you will understand. Okay, so now, as you can see here, our r theta need to minus this distance. Okay, let me see. Minus this distance. So this distance, how to calculate? Very simple. So just observe. Okay, let me write down first. Maybe it will be more clear why we calculate, so I don't confuse, or everybody don't confuse. So C, oh my god, it's C. Maybe I should name it different because it's the same as the center point. Just D. Then, okay, let's call it D and E. So your D value will be your R theta minus your blue color. So what's this part? What is this part? So this part is very simple. So as you can see here, your C prime A and B, right, is actually R theta. And then B, what is B? B will be your Y value, which is R. Okay, so this distance, let's call it H. Maybe W. Okay, H. Okay, so this value actually is also using the feature of the circle. So we will get, it will be, let's see, because there's theta here and you want to calculate this, so it will be, I don't want to use this color, why I use that? It will be psi theta, R psi theta. Okay, R psi theta. Your H equals to R psi theta. So now you will know your D is R theta minus R sine theta. Now we want to know what about E. So E, let's observe here, also the same concept. Use the feature of the circle. This is your R, right? So when your R minus this distance, your purple distance, let's call it Y, I don't know, G. Okay, so your R minus G will be your Y value of the P prime. Okay, so how to calculate that? Let's see. Okay, let's just change the color back so we don't get confused. V equal to this and your G, which also, if you know the trigonometry, then you will know the G will be your cosine, R cosine theta. Okay, so now we get the parametry of the cycloid, which is your P prime is equals to, not equals to, your P prime will be, okay, R theta minus R sine theta, and then Y will be your R minus R cosine theta. Cool. This is very handy. Once we get this parametric equation of your cycloid, and now we could start to calculate its length. So I just draw randomly. This is not like according to a scale or something. Let's say your circle rotates from 0 to pi, like one round. So the trajectory, that's assuming trajectory is this. It's not accurate, I know, just concept. Okay, change the transparency. You want to know the length of its trajectory. So to know that, we need to use the application of integration. So integration from 0 to pi and to 2 pi, 2 pi, one round, right? One circle of your ds. And let's do it step by step. So what about this? Remember? So our length equation ds is equals to the square root of dx dt square plus dy over dt square with respect to t, which here we don't have t, is theta. Yeah, the same. Just plug it in. So in order to calculate the length, it will be from integration from 0 to 2 pi of square root of, let's calculate it here. So your dx over dt will be your r minus r cosine theta. And it's square. Okay, and then now dy over dt will be, okay, r minus r sine theta because it's square, so we don't need minus. And then square with respect to t. And let's make it organized integration from 0 to 2 pi square root of r square minus 2r square cosine theta plus cosine square theta. Okay, r square. I forgot. Okay, plus r square sine square theta with respect to t. Okay, so now let's still keep it organized from 0 to 2 pi square root. Why you keep doing that? Okay, finally, thank you. Okay, so we all know this will be r square, 2r square, 2r square, and here is 2r square too. So will be 2r square 1 minus cosine theta with respect to t, which let's make it organized, will be square root of 2r square root of 1 minus cosine theta with respect. Oh, why respect to t? Okay, I was wrong. d theta. Okay. So now we get. So how to calculate this? So when you see this, then you can substitute with trigonometry, because your sine theta will be 1 minus cosine 2 theta all over 2 square root. So your sine theta divided by 2 will be square root of 1 minus cosine theta all over 2, which will be your square root of 2 sine times sine theta all over 2 will be your square root of 1 minus cosine theta. So let's substitute these into here. Okay, so square root of each square is 2r times integration from 0 to 2 pi, and then your sine theta divided by 2 with respect to theta, which we can divide it by 2 here, so times 2 here will be your 4r integration from 0 to 2 pi sine theta divided by 2 with respect to theta divided by 2. So now this will be this becomes very simple. Cosine theta minus from 2 pi from 0 to 2 pi. Okay, so now will be 4r minus cosine pi minus, I think I can keep this out, minus cosine 0, which will be 4r. Okay, this one will be 1, and this one will be oh, sorry, here also have minus. Oh, okay, I panic. So plus 1, which will be your 4, no, sorry, bar is 8 times r. Okay, so this is the how you calculate the length of the cycloid.